All right, this is we're right on the hour. This is Carolyn Jacobs, and I'm in the education department at GBH. We are thrilled to have you. Thank you for joining us. This is the second in a series of webinars that are grade specific, all around a collection of resources for science. And we had the K2 one last week, and 6-8 and 9-12 are coming up soon. The collection of these science resources is called Bringing the Universe to America's Classrooms, and it's produced by GBH in collaboration with NASA and available free on the website pbslearningmedia.org. We're using Zoom tonight as our platform, and Zoom webinar, excuse me, and only the presenters will be on camera and with the microphone, and we invite you to go into the chat and introduce yourselves, and certainly collaborate with each other and the presenters. When the presenters are not speaking, they'll do their best to respond and be active. We do have Angelica from GBH education team who will be in the chat also. Saul just joined us. Hi, Saul. You're on camera right now, and you could turn off your video and mute and then come back on later on when it's time for you to come. Can you hear me? Okay, great. Okay, good. Cool. Thank you. Okay, so at the end of the session, you'll have a link for the survey. Our research department puts it together, and we really appreciate you answering a few questions that help us do a much better job. At the end of the survey, you can download a certificate that acknowledges that you participated. The session is sponsored by GBH Education, which is part of GBH Boston, Boston's public media station, and also PBS Learning Media. That's where the collection of Bringing the Universe to America's Classrooms lives, along with thousands of other resources, all free for K-12 across the curriculum, but we are very strong in science. We invite you to go to the site and explore it if you haven't already. Sign up and make full use of looking at thousands of resources that include lesson plans and videos and interactives, etc. Our main presenter tonight is Toby McElhenney, and he is a producer at GBH Education and very involved in the creation of what you're going to see tonight. And he is joined by two wonderful educators, Kiara Reed and Saul Calzadilla, excuse me. I even practiced that, Saul. Kiara teaches third grade. She's originally from the Midwest and then moved east and now teaches at Centennial Academy Charter School in downtown Atlanta, Georgia. Centennial Academy is a conversion charter school. It serves a very diverse group of K-8 scholars, including many students who come from homeless shelters in Atlanta. Overall, Kiara says her goal in teaching is to empower scholars to learn, grow, and make an impact, bettering the world around them. Lovely. Saul is a STEAM teacher of multiple grades at Whitsitt Elementary, which is a pre-K to 4 environmental engineering magnet school in Metro Nashville, Tennessee. Saul believes the best learning comes through authentic experiences rooted in STEAM, in the STEAM-based curriculum. And in other words, it's what he described it, he is a strong proponent of learning that has deep meaning and creates lasting memories for his students. Okay, our agenda tonight, and we have a fast and furious webinar that will last 45 minutes. Toby's going to kick things off with an introduction to the collection of resources, talking a little bit about the pedagogy, how we created them, and giving you some specific examples. And he'll be followed by the two teacher presentations, giving you examples of how the resources have worked for them in their classrooms. And then I'll come back on for a few minutes with some closing remarks. Okay, I'm going to turn things over to Toby.
Good evening, everyone. Hi, I'm Toby McElhenney. I am a media producer at the Ed Department at GBH, and I just want to welcome you all and also just say how much I appreciate the work you all do. Although I am not a teacher, I've had the pleasure of visiting classrooms across the country many times with the camera so I can share all the wonderful work that you're doing with other teachers. It's given me so much admiration and appreciation for what you do, and I can tell you that I could not do your job. So it gives me a lot of pleasure to be able to work on resources that are hopefully helpful to the work you're doing day in and day out. So that work has been at GBH primarily for bringing the universe to America's classrooms. This is a collaboration with NASA and teacher advisors across the country. Just note that this collection, although it addresses many key science ideas, it's not meant to be a curriculum or provide units. It's designed to be supplementary and flexible for your curriculum. Next slide, please. So here's our homepage. You can see that it's organized by grade band. And once you get in there, it's organized by topics, and then at a lower level, each resource notes how it is aligned to the NGSS. All the materials are designed to engage your students to not just the DCIs, but the specific NGSS science practices. Next slide, please. So the type of resource we have in each grade band and each topic collection, there are lesson plans that usually have 2 or more resources and suggestions how you can integrate them into your class over a period or 2. There are also interactive lessons that are opportunities for students to engage with media essentially over a series of slideshows that allow students to work independently, but also can be led by you if with a group. There are also what we call media galleries or single asset resources where you'll find different types of media. There's videos, images, as you see there, models, simulations, games, and other types of tools for you to engage your students in science phenomena and the science practices. Next slide, please. Even though these resources are supplementary, they come with lots of supports. You can see the arrows there pointing to support materials for both teachers and students. There are many accessibility features, including a screen reader. We're working right now on translating these resources into Spanish. And I've been actually involved in translating many of the videos into scripted video for visually impaired and blind users. And just as an interesting note, we've gotten some evaluation from teachers that these descriptive videos work very well in mixed classrooms as well. Next slide, please. So if there is, I guess, one phrase I'd like you to go away with from this is that the media is really there to help enable observations in your classroom. We're making data and phenomena accessible, and we're trying to do that in a way that enhances but doesn't replace the type of observations you could already make in your classroom. Often these media provide you opportunities to share with students observations and analysis that would either be difficult or even impossible to do in a classroom. You can see a screenshot there of a visualization from the NASA Science Visualization Studio, with whom we've been partnering very closely over the last 5 years. They do a fantastic job at taking data sets and making them visual. Next slide, please. So again, I think you'll hear me hammer this point home again once once, twice, three times, probably too many times. We are providing media that replaces real life, that doesn't replace, but enhances real life hands-on experiences. So as I mentioned before, sometimes this is media that would be difficult to observe on any given day in your classroom. That you can see a picture there of the past sun across the sky. If you want to know what the sunbursts are, you're going to have to go into our collection, and you'll find that in the support materials in the background essay. Next slide, please. But we can even go beyond one day in terms of observations. You can see that these satellite images of Atchafalaya Bay in Louisiana were taken over many years. Next slide. And so these types of satellite images that we get from NASA, we look to share with you, but we had to think about how do we make this sense? How can we deliver this to you in a way that students can make sense of it? So this is actually back from our this video that you're going to see is back from our prototype days, where we took these satellite images that were taken over roughly, what is it, about 20 years. And why don't we take a look at the first minute or so of this video. So this video does not have sound, but you see that actually we added the years on there, and then also some details to watch closely to provide some context exactly what's going on. These are false color images. So we were able to point out not just location, but what the colors mean in the photographs. So we can provide some scaffolding for your students. And then why don't we stop right there? But the video goes on. And then once you have some of this information, it allows you to watch the change happen over time at a slower rate. These types of contexts and here, sorry, before we go on, can you just back up one slide? Yeah, just wanted to note that this particular video is not necessarily representative of all we've done in terms of how we annotate videos, but it was really sort of our launching point of how do we shape this type of media so it's useful for your classroom. Next slide. So we'll focus now on some new hot off the press resources, waves and information transfer. The bullets on this slide, at least when I first saw them, seemed a little bit technical to me, but we really worked hard to make sure that this type of DCI could be represented in a way that would be fun and engaging and accessible for your students. So next slide, please. And the way I think we thought about would do that was, let's see these concepts in the real world. So waves are universal. Let's start off with that idea that it's not something that's abstract, that's just a part of academic science. It's something that's all around us. And here you see a few different examples. We can play the sound wave video. We use picture and sound. Sound, consider another really useful way for your data, your students to observe data or have a chance to make observations. And actually at the end there, since it's a NASA project, the last image on the right there, the bottom right, on it, that's sand waves on Mars. We had to include that just to show you that waves truly are everywhere. Go to the next slide. sorry, yeah, there we go. Water wave motion. So water waves don't move objects forward. This seemed like a rather abstract concept to begin with, but we were able to find some real world video. If you play this video, you'll actually see that the water moves and you watch it with the camera following the waves. But if you keep your eye, and this is where some of the support materials are really helpful, you keep your eye on the birds, you see that they actually don't move in space. Let's go to the next slide, please. And now we can see the same concept with animations. You'll find that many of our resources use multiple media experiences for you to drive home the same point, and hopefully these different types of media help complement each other and engage your students and enhance their learning experiences. So let's take a look at the interactive lesson from where we find these two videos. So let's take a look on the video on the left. So here's the video of can we open up that? There we go. Same idea. The object, the wave, the object stay in one place. Or if we look on the video on the right, give it a little bit of real world context. The way it's moving, but the bird is staying in one place. Great. Next slide, please. Also part of this DCIs is information transfer. How do you go from a concept that deals in ones and zeros? I remember the first time that was explained to me about how digital media works. Didn't make much sense to me, but I think we found a fun and engaging way to use with your students. This interactive allows your students to manipulate ones and zeros and see the code that it produces. If you click on that. And this is as a building block to think about our next concept of resolution. Actually, Carolyn, I think you could just go to the next page in the interactive. You click on the upper right. There we go. So if at the bottom, you can see that you can choose an interface of 16 squares or 64 or 256. And each one, if you choose the duck picture there on the left in the middle, you can see that it's different squares give you different resolution. And then on the right, you see what that looks like in code. And then you can also choose your own picture if you click on the marker there. This gives students a chance to play with the interactive and see what they come up with. Great. Can we go to the next slide, please? In many of the resources that we share with you, we use different types of data for evidence. Often that's just different types of media, but can we go to the next slide? So in this resource, Drought Affects California's Water Availability, you see that we use satellite images, graphics, as well as on the ground images for students to compare and contrast. And all of the information that we share is considering your grade band. And I think, we consider information, we consider it data, just the year or even just the details that we share in the key. We're trying not to overload your students, but we want to give them information that helps them make sense of what they're seeing. Next slide, please. For 3.5, connecting Earth and space perspective, it's a tough thing to do because you're now having to consider two different perspectives at once. What you're used to seeing on the ground level and what's actually happening at in an Earth, Moon, Sun, and system. And before we go to that, sorry, I know we're running out of time. I just want to show one more thing about the interactive. We wanted to create something where students get to play with what happens over a month with the sun's path through the sky, what that means in terms of moon phases. And this is a lot to comprehend at once. So, but we're giving sort of students the driver's seat here where they can go forward an hour or a day, they can go backwards and they consider what's happening at the ground level, or when we're looking down at the North Pole of the Earth, to meld those two perspectives together and begin a more robust understanding of Earth, Moon, and Sun system. Next slide, please. So this is considering daytime in New York City and Melbourne. This is a type of graph that we share in interactive lessons, as well as some handouts for you to share with students. It's another example of where they can look at data and make analysis and make sense of what they're seeing. And in this question is, in this case, is just to consider this question of why are the patterns of this daylight so different? Why is it so different in New York versus Melbourne? Next slide, please. And a great example, this is not the same specific data as New York City and Melbourne, but this is a video where we see the path of the sun through the sky on June 21st, the summer solstice, and the winter solstice on December 21st. If we have time, let's just take a look at the first part of the video.
Today is June 21st, and we are about to watch the sunrise in Boston. Pay attention to the location of the sunrise. Is it exactly to the east? And there's the sun rising already at 5:12 a.m.
This video was produced in collaboration with the Worldwide Telescope at the Harvard Smithsonian Center for Astrophysics. And
the sun is just about to hit its highest point, and there.
If we had a little more time, we'd see that the highest point for December 21st is much lower in the sky, as well as has quite a difference from where it rises and sets. This is yet another example of where this might be difficult or possible to observe in one day or even over a year in your classroom, and hopefully it really enhances what you're already doing. Next slide, please. My one final thought, this is an example of a interactive lesson. This is what we a plug-in arrangement where you're having students actually build their own little model of explaining why summers have more daylight. We are giving them choices of which Earth's tilt to choose. In fact, here you're seeing two examples of the Earth tilted to the right, but the students have choices where it tilts to the left or it is straight up and down, and they have to place those Earths in the digital interface. And so this is a way for them, once again, to make sense of some of the concepts, but also gives you a chance to assess their learning. So that's hopefully gives you a flavor of some of our collection, and how you integrate, of course, is how you best see fit. So to see how some of those resource in action, where the real magic is happening, I'll hand it over to Kiara and Saul. First to Kiara.
All right. Hello, everyone. So I am Kiara Reed. Again, and I'm a third grade teacher, and I've also taught second grade. So I've used PBS Learning Media in both grade levels. All right. And so I've used PBS Learning Media resources to supplement many content areas, because once you go on the site, you'll see that there's a lot in there for pretty much all content areas, but specifically in science and using these Bringing the Universe to America's Classrooms resources. I've definitely used the one on the daylight hours, because that's a second grade standard. But this year I used a resource to help supplement our science standard for pollution. All right. So again, we were starting with a PBO project, and so the anchoring standard was for pollution. So they're obtaining, evaluating, and communicating information about the effects of pollution. And so I had to find a resource that helped some of my scholars understand the distribution and uses of water. I chose the resource that I did because it connected seamlessly to what we were already learning, and it extended our learning. And it helped to answer two questions: how much water can we actually use on Earth? And how does this connect to the idea that we need to conserve and protect our water sources? So I'm going to have Carolyn play the video, and then we will go into a little bit more of why I chose that. So Carolyn, if you could play just about 1 minute of that, please.
As humans, we're well aware we need water to live. Fortunately for us, we live on a water planet. But that doesn't mean we have an entire globe of H2O to use as we please. So just how does the usable water break down for us? A giant 97% of Earth's water is in the ocean, so we can't use that. 3% is fresh water, but even in that small sliver, about 2% is locked in glaciers, ice caps, and groundwater. That leaves about 1% of the fresh water on Earth that is accessible and usable by humans. Let's imagine all of that accessible fresh water fits into this tiny pool. Now we'll get to some small numbers when we look at global freshwater.
Thank you. All right, so heading back to the presentation. Yep, and next slide, please. Yes, so again, why did I choose this resource? So our task at hand was to write an opinion piece that answers the question: as a social activist, do I support or oppose the closing of the Dakota Access Pipeline? And so we were trying to, we were doing this because it tied into water pollution. But one of my scholars asked, well, Ms. Reed, why can't the Standing Rock Sioux Native Americans just go and use water from somewhere else. And so I was trying to find a resource that was efficient, helpful, and accessible for scholars to understand that even though we live on a planet that is majority water, we can't use all of that water. And so this resource did just that. And as you could see, it broke down, it gave the pie chart, and then later on in the video, it also talks about some other, how we use a lot of that usable water, the fresh water that we have. And so again, this resource, I wouldn't have been able to really explain that to them without the use of PBS Learning Media. I can say that, but seeing it in a video and having those visuals there definitely helped. So yeah, so this was the other resource that came along with the distribution of water. And so again, it's visually appealing, easy to comprehend. It led to deeper conversations, and it connected directly to the standard, which was super helpful. And so ultimately what my scholars were able to do, they were able to use this resource to cite in their writing why they either supported or opposed the Dakota Access Pipeline. Next slide, please. All right, so other thoughts and some tips. So again, like I said, I use these resources often. When I am lesson planning, I will go in and type in the content or the topic that I'm teaching, and of course, toggle between the grade bands, and so things will come up, and as mentioned earlier, it will outline the standards that are there. But other things, the video, as you could see, it had captions, and that's useful for scholars with special needs, but then also it's been very helpful virtually as well. So there are support materials for teachers and for students. And so definitely before I teach, I go through the background reading. And so that just helps me to be up to date on any material that I need to know that or misconceptions that scholars may have, so that I am teaching this material in a better way. And then also for the scholars, so it has discussion questions. So of course I'll use those if necessary, and that transcript down there as well. And then lastly, it also connects to Google Classroom. So as I said, my scholars were using this resource for their writing. And so I didn't have to keep going to find the resource to give it to them. They didn't have to say, Ms. Reed, where do I find this? Instead, they were able to just click right into their Google Classroom and pull it up because they are intertwined. And you'll see that once you go onto the website. So overall, like I was saying, it's great resources that are very helpful, very accessible to all scholars, all learners, and it's definitely enhanced my teaching and the curriculum that we have at my current school. It definitely takes it to a deeper level and allows me to extend the learning when possible. So thank you for this, and if you have any questions, definitely type them in the chat. Thank you.
Hello, am I on?
Yes, you are, Saul. Go
All
ahead.
right, fantastic. Thank you so much. So for our school and our class, I'm the STEAM teacher, and I only get to see our students about twice a week because we're all virtual, and it's just 30 minutes in each lesson. So we really have to pack a lot into a very short amount of time. And what our question was, our standard was that we're interpreting maps to determine that the location of mountain ranges, deep ocean trenches, and volcanoes and earthquakes all occur within patterns. So we wanted the students to create a project that would demonstrate their understanding of this Tennessee state standard. So the way we presented it to them was through the essential question of how can we use the data, maps, and patterns to make informed decisions about traveling safely. And what we kind of follow within our school is this engineering design process that you see here, where first we ask the question, then we imagine potential answers, we plan, we create, we improve, and it's been really useful. Yeah, so the first thing that we wanted to introduce the students to was that we wanted them to get that there's these tectonic plates, and the tectonic plates are very connected to the presence of earthquakes and volcanoes in the world. So through using the PBS Learning Media, we allowed the students to sort of independently examine one of these resources, being this Volcanoes and Earthquakes Interactive. And you can see up here in the corner, there's the layers. So first we showed them, here's where all the earthquakes are in the world, these green dots. And then that opens up a discussion of like, what do we notice? Who can notice any details about what's going on in the ocean? Are there any places that there are more earthquakes than not? And then we're able to add the volcanoes layer as well. And then kind of ask the same questions. What do we see? Where are there more volcanoes? And then finally, we're able to add on this third layer of the tectonic plate boundaries. And then again, you're leaving these open-ended discussion questions of now what kind of connections can we make about earthquakes, volcanoes, and these tectonic plate boundaries. Because once again, we want the students to arrive at these understandings on their own instead of having someone just sort of sit down and say, here's how it works, here's what it is, here's what you need to understand. And this website is really great for that. Yeah, so then another thing that was also excellent along these same lines was the Seismic Explorer thing. And as you can see here on the page, it says this is for grades 9 through 12. And I was teaching a 4th grade class, but I felt like this resource was still really excellent because it shows these amazing visuals of the activities of earthquakes over the past 3 decades. And I think it's just like a really quick clip that we can show of how this works so you can see down here from 1980 all the way up to now. And as we showed this to the kids, we want them to arrive at this understanding that the Earth's surface is not just a static, unchanging thing, that it's actually very much moving and changing and always under different pressures and stresses from what's going on underneath in those deeper layers. So this very dynamic visual was great because they can see it and say like, oh, wow, there have been a lot of earthquakes, and most earthquakes will happen where previous earthquakes happened. So this is again reinforcing that connection between earthquake and volcanic activity and those tectonic plates. And that will lead them hopefully to the understanding that the Earth is a dynamic system and that these tectonic plates are always moving around and grinding up against each other, and that it's a very active thing. So one of the big concepts that we wanted our students to understand was the difference between magma and lava, and how there's the layers of the earth and the mantle, which is always leading to the formation of new crust. So one of the big questions that the kids had was what happens to lava as it cools, and how is new land formed? So we can just play a couple of seconds of this video, which is some really amazing footage of an underwater volcano as lava emerges in the ocean trenches. And again, this was just really great stuff for the kids to see, not something I can show them in the classroom easily.
Scientists believe that 80% of the volcanic eruptions on Earth take place in the ocean. Most of these volcanoes are thousands of feet deep and difficult to find. But in May of 2009, scientists captured the deepest ocean eruption ever found. Nearly 4,000 feet below the surface of the Pacific Ocean, in an area between Samoa, Fiji, and Tonga, the West Mata volcano was discovered. The explosions of molten rock were spectacular. This volcano was producing Bonanite lavas, believed to be among the hottest erupting on Earth.
So allowing the students to see these really great visuals really led to solidifying that understanding of what happens to this molten lava as it emerges into and comes in contact with the cold ocean water, which was really great for a discussion. So part of what our project was, we wanted to have the kids do this travel research thing on how to travel safely. So we are able to look at this Alaska volcano and earthquake case study so that they were able to create this travel guide. And the case study is really great because it shows a lot of really great visuals, and you get to see these mountain ranges, you get to see the effects of these earthquakes and what they do to the land. And you can see how, maybe something like a travel safety plan would be important if you were traveling in some of these places, as you can see from some of these pictures. And again, just really high quality content that was really great for inspiring discussion in the kids and bringing in that kind of wow factor. So when we presented the project to the kids, we asked them to sort of follow this rubric. Do we have a map with the location of the volcano or earthquake? Can you include the name of the place that you're talking about? Can you explain why it's dangerous? Can you include 5 tips on how to stay safe if I travel there? And of course, complete sentences, correct grammar, and is your project neat? So in addition to this, on the next slide, we gave them some choices of how they wanted to create their project. Since we're all virtual, we wanted to give them as much choice as possible, that they could create a poster, write a song or a poem, or make a Pixton story, which is like a little Bitmoji kind of a thing. A lot of our students actually chose to make PowerPoint presentations because, we're always using PowerPoints as teachers. So I guess they were inspired by that. So I have some examples of student work here as well. This is we have a whole PowerPoint here. It was only 3 slides long, but I think that the student did a really great job sort of trying to get this information in and describing, be careful where you travel, make sure you're traveling to Hawaii, and make sure, to be prepared. So just really great information that they've included. We can look at the next slide. And here, remember, we had to have their 5 safety tips. So if you want to survive a volcano, you always have to be prepared. Make sure you have your safety kit with you, and then all the things that you should have in your kit. And they included little pictures, which was just great. And then talking about some of the dangers of the earthquake or volcano specifically that they were talking about here in Hawaii. And this student totally took it on their own to say, the differences between indoor and outdoor dangers, which I thought was really cool. And then on the next slide, I have some different examples of what other students included. These are just a variety of things that they included. And you can see that they were just really excited to create these projects and show us how much they had learned. And on the next slide, here we have a student who she went to make her own volcano alert system to show people, how to follow the signs of, if it was safe to travel or not. The title page from this slide with the lava, I was just so happy to see this there. We have a very high EL population. So seeing the kids working like this and creating these great PowerPoint presentations, even if it's not, perfect spelling or anything like that, they're still doing an amazing job, and they were so excited. And again, this topic is just really, really engaging. You can't get engagement like this from anything else, lava and volcanoes and stuff. And I feel like PBS Learning Media really did a lot to bring that into the classroom. So it allows us to spend more time with the students working on their projects that they were doing, and less time having to write lessons or, go on YouTube and find like a time sensitive, appropriate video that shows just what I want, when instead I can just go to here and just type it in and find tons of content that are high quality and free. And it comes with all the background support for teachers. It comes with in Spanish, it comes with subtitles for our ELs. So it's just really great, and it allows us to suit our purposes. Like, for example, this project that we were doing where we wanted to create a travel guide, and we can spend more time with the students doing their projects instead of having to plan out and create a lot of content.
Thank you, Saul. I'm going to come back on camera here. I think I neglected to mention that both Saul and Kiara were GBH teacher advisors on this project, Bringing the Universe to America's Classrooms. And they were a part of a very important group of teachers who gave us advice and feedback, which happened throughout the whole tenure of the project over the last 5 years, as we were producing more of the resources to publish on PBS Learning Media. So thank you, Saul and Kiara, and thank you, Toby. Just a quick reminder that everything that you saw tonight is available on this website. I know that Angelica has been posting a lot of links in the chat. I just wanted to give you a couple of visuals of other collections of resources on the site. These two others of interest to science teachers, but I know that 3-5 teachers often teach multiple subjects or all subjects. So No Nonsense Grammar is an example of a collection that is obviously not for science, it's for ELA. And the Young Voices for the Planet is a new collection, and I just stumbled upon it and fell in love with it. So I thought I would showcase that also. The webinars, I neglected to put the grades K2 recording link in here, but you'll get that in the follow-up email or on the resource document. And then we have the 6-8 next week, 9-12 the following week. And then at the end of March, we're going to have 2 webinars, one for K5 and one for 6-12, about English learner strategies in science, and also featuring a lot of media. So we'll make sure that you get information about those things. This is the link for the survey that I mentioned in the beginning, where you can download a certificate. The survey will stay open for about a week. I think when you close out of your browser window from tonight, the survey should pop up automatically. Very quick, but very important for us to continue to try and do a better job. And that link will be posted in the chat. In the resource document that you're going to have access to, there's a link to the slide deck, a link to the survey, a link to other recordings, and all of the links to resources that we showed tonight. We're very active on social media, GBH Education, so we invite you to follow us and stay up to date with what we're doing. And this is my contact information, Carolyn Jacobs, Carolyn_Jacobs at WGBH.org. We recently went through a name change and we're no longer WGBH, but we haven't changed our email yet. Anyway, thank you very, very much to Toby, Angelica, Kiara, and Saul. I really appreciate it, and appreciate all that you are doing, attendees, teachers, and coming to the session. Best of luck to you with good health. Get vaccinated soon, I hope, and come back and see us for another session. Thank you. I'll keep the chat open for another minute or so, and then we'll close out the meeting.